1943. The world is a mechanical hell of grinding gears, screaming sirens, and burning oil. From the freezing waters of the Atlantic to the humid jungles of the Pacific, the largest conflict in human history has reached a brutal stalemate. The ocean has become a massive graveyard. Every single day, thousands of tons of steel and thousands of human souls vanish beneath the waves. The problem facing the Allied command was as simple as it was deadly. Rockets and bombs of that era could fly, but they couldn't think. They had no eyes. They had no brain. Imagine a B-17 flying fortress dropping a payload of 10,000 pounds of high explosives from 20,000 feet. To the observer, it looks like power, but the reality was a statistical nightmare. In high-altitude bombing, the chance of hitting a specific target, like a moving destroyer or a hardened bunker, was less than 1%. Every miss meant another day of war. Every wasted bomb meant another shipment of supplies destroyed by German U-boats. The military was desperate for a miracle. They experimented with radio control, but the signals were easily jammed by the enemy. They tried mechanical gyroscopes, but they were too crude, too heavy, and too prone to failure. They needed a guidance system that was small, light, and immune to electronic interference. They needed a brain that could think faster than a fuse, but smaller than a pilot. And then, into this atmosphere of desperation, stepped a man named Burris Frederick Skinner. To the world of academia, he was a giant, the father of modern behaviorism. To the generals in Washington, he was a scientist whose ideas sounded like a dangerous joke. Skinner didn't look at a pigeon and see a common bird. He didn't see a pest of the city streets. He saw a biological masterpiece. He saw a computer that had been refined by millions of years of evolution to do one thing perfectly: track a target with absolute focus. Skinner's laboratory in Minnesota was a place of strange and unsettling contrasts. It was a world where the cold precision of military engineering met the warm, erratic life of the animal kingdom. For years, Skinner had been proving that behavior wasn't a mystery, it was a machine. He had taught rats to navigate complex mazes with the precision of a clock. He had trained pigeons to play ping pong, to recognize shapes, and to react to light with millisecond accuracy. But now, the stakes were no longer about psychology papers. They were about the survival of the Atlantic convoys. The project received a code name that felt like something pulled from the pages of a science fiction novel: Project Orcon, Organic Control. It was a name that disguised a reality so bizarre that even those working on it struggled to believe it was happening. The training began in absolute secrecy, behind locked doors and guarded gates. It was a symphony of repetition, a relentless grind of stimulus and response. Day after day, month after month, the pigeons were integrated into the machinery of war. They were placed in tiny, custom-made canvas harnesses, miniature straitjackets designed to keep their bodies perfectly still, leaving only their heads and necks free to move. These birds were placed in translucent screens. On these screens, a shadow would move, the silhouette of a Nazi battleship like the Tirpitz, or a Japanese aircraft carrier hidden in the Pacific fog. To make the system work, Skinner developed some technology that was decades ahead of its time. He coated the glass screen with a faint layer of gold. This gold layer carried a faint electrical charge. When the pigeon's beak hit the screen, it completed an electrical circuit. One peck was a signal, 2 pecks was a command. If the bird pecked the center of the shadow, a small solenoid clicked, and a single grain of hemp seed dropped into a tray. Peck, grain, peck, grain. This wasn't training, it was programming. The birds became obsessed. They weren't fighting for democracy. They weren't fighting for the Allies. They were playing a high-stakes game where the only prize was survival and the next meal. Skinner knew that the skepticism of the military was his greatest enemy. He had to prove that his birds were tougher than the technology they were replacing. He put them through a gauntlet of horrors.
He placed the pigeons in pressure chambers to simulate high-altitude flight. He strapped them into centrifuges, spinning them until they experienced G-forces that would have caused a human pilot to black out. He blasted them with the deafening, bone-shaking roar of experimental jet engines and the blinding flashes of simulated explosions. The pigeons didn't flinch. As long as that shadow moved across the golden screen, their focus remained unbreakable. Their reaction time was lightning fast, far faster than any human operator sitting in a control room miles away. Skinner had succeeded in creating a guidance system that was immune to radio jamming. You couldn't jam a pigeon's instinct. You couldn't confuse a bird that had been conditioned to see only one thing: the target. Imagine the nose cone of a Pelican missile. In the space where today we would find microchips, sensors, and fiber optics, there sat a wooden frame holding 3 pigeons. This was Skinner's masterstroke: biological democracy. He knew that even the best trained bird could make a mistake, so he used 3. If one pigeon got distracted or fainted from the force of the rocket's acceleration, the other 2 would maintain the course. The missile's servos were wired to follow the majority. It was a living, breathing neural network, a concept that would not be fully realized in digital form for another 50 years. The accuracy was terrifying. In simulated tests, Skinner's pigeons achieved a 99% success rate. They could steer a heavy, unpowered glider directly into a target with the precision of a modern laser-guided bomb. They didn't panic, they didn't tire, they didn't ask questions about the morality of their mission. But as the project moved closer to reality, a dark cloud began to hang over the laboratory. The military brass eventually came to witness a demonstration. They stood in a cold, dimly lit room, watching a pigeon peck frantically at a golden screen. To the generals, it looked like a joke. It looked absurd, humiliating, and beneath the dignity of the United States Navy. They saw a pigeon-brained idea that belonged in a circus, not on a battlefield. But Skinner saw something else. He saw a tragedy that no one wanted to admit. This was a one-way ticket. A pigeon in the nose cone of a missile is a kamikaze by proxy. The bird doesn't know it's flying into a wall of fire. It doesn't know that its final success will be its own destruction. It thinks it is milliseconds away from its next grain of corn. And in that final moment of impact, the reward isn't food, it's total annihilation. Skinner was a scientist, a man of logic, but even he must have felt the weight of what he had created. He had taken one of nature's most innocent creatures and turned it into a suicide bomber. Project Orkan was eventually mothballed as the war drew to a close. For a brief moment in the early 1950s, during the height of the Cold War, the military revived the idea. They needed a way to hit Soviet ships, and electronics were still not reliable enough. New tests were conducted, new birds were trained, and once again, the pigeons proved their worth. They were faster and more accurate than the early computers of the time. But the world was changing. The invention of the transistor changed everything. The machine, finally and permanently, replaced the bird. Not because the machine was more accurate. At first, it was actually slower and prone to more errors. The machine won because it didn't have a soul. You didn't have to feed a transistor. You didn't have to clean its cage or worry about its health. And most importantly, you didn't have to look it into its eyes and wonder what it felt like to turn life into expendable ammunition. Today, Project Orkan is a footnote in history, a curiosity buried in the National Archives. We tell the story to show how desperate and strange the days of World War II were. But if you look closely at our modern world, you will see Skinner's dose everywhere. When you touch the screen of your smartphone, you are using the same principle of electrical completion that Skinner used on his golden pigeon screens. When we talk about neural networks in artificial intelligence, we are using a digital version of the biological democracy Skinner built in a wooden frame in 1944. We think we have moved far beyond the crazy ideas of the past. We use GPS, satellite links, and sophisticated code to guide our drones. but we are still standing on the shoulders of Skinner and his pigeons. We have simply replaced the living beak with a line of digital code. The ethics remain the same. The pursuit of the perfect weapon continues. The pigeons today are free. They fly over our cities, ignored, unobserved, and unburdened by the weight of war. No one locks them in missiles anymore. No one trains them to hunt ships. But in the dusty archives of history, the blueprints remain. A reminder that in the heat of conflict, humanity is willing to use anything, even the most innocent of creatures, to achieve victory. The story of the pigeon rocket is not just a story of a failed weapon. It is a story of how far we are willing to go and what we are willing to sacrifice in the name of precision.